The search for exoplanets has been one of the most exciting and groundbreaking endeavors in the field of astronomy. However, discovering 5 exoplanets that could be made entirely of water has taken the search to a new level. These mysterious and intriguing planets have captivated the attention of scientists and space enthusiasts alike, raising many questions about the potential for life beyond our solar system. Join us as we probe deeper into the fascinating world of exoplanets and explore the possibility of an aquatic alien world. Kepler-62e and Kepler-62f. Astronomers have made an exciting discovery. They have found a planetary system revolving around the star Kepler-62, home to 5 planets. Even more intriguing is that 2 of these planets are located in the habitable zone, the perfect distance from their star to potentially support liquid water on their surface. According to Harvard-Smithsonian Center for Astrophysics researchers, these planets, Kepler-62e and Kepler-62f, are water worlds. In fact, they are entirely covered by a global ocean, with no sign of land in sight. These planets are unlike anything in our solar system. They have endless oceans, said lead author Lisa Kaltenegger of the Max Planck Institute for Astronomy and the Harvard-Smithsonian Center for Astrophysics. Lisa thinks there might be life, but it could differ from what we know. Picture this. Life on those planets would be aquatic, without access to metals, electricity, or even fire for metallurgy. However, these planets would still be breathtakingly blue, orbiting a warm orange star. Kepler-62 is a star in the Type K category, which is somewhat smaller and cooler than our Sun. 2 fantastic water worlds, Kepler-62e and Kepler-62f, rotate around this star in 122 and 267 days respectively. These remarkable planets were discovered by NASA's Kepler spacecraft, which can identify planets that transit or cross the surface of their host star. Measuring a transit provides astronomers crucial information, such as the planet's size relative to its star. Kepler-62e is 60% larger than the size of Earth, while Kepler-62f is about 40% larger, making both super-Earths. Although they are too small for their masses to be measured, astronomers anticipate that they are composed primarily of rock and water, lacking a significant gaseous envelope. According to computer models, Kepler-62e, the warmer of the 2 worlds, is likely to have slightly more clouds than Earth. However, Kepler-62f, which is farther away, would require significant carbon dioxide to create a greenhouse effect and warm up enough to support an ocean. Otherwise, it could turn into a frozen, ice-covered planet. The discovery raises the possibility that some stars in our galaxy may have 2 Earth-like planets with oceans and continents, where technologically advanced life could develop. Trappist-1e and Trappist-1f. The Trappist-1 star system is home to 7 rocky planets, each similar in size to our very own Earth. These planets are a mere 40 light-years away, and their discovery in 2016 and 2017 has piqued the interest of scientists and space enthusiasts alike. 3 of these planets are located within their star's habitable zone, meaning liquid water could exist on their surfaces. But the big question remains, are these worlds truly habitable? Although we don't have an answer yet, a groundbreaking study from August 2023 suggests that some of the Trappist-1 planets might indeed be home to water. And if that's the case, we could be looking at a whole new frontier of habitable planets to explore. New research suggests that the Trappist-1 exoplanets may still have the potential for life despite previously believed harsh conditions. The study used a novel modeling technique to analyze the evolution of planetary atmospheres and found that water may still exist on these planets. This increases the possibility of life developing on Trappist-1 exoplanets. Scientists at the University of Bordeaux have developed more realistic models of water-rich planetary atmospheres, which may help constrain where life in the universe might exist. These models focus on enormous water-rich atmospheres, a crucial step in evolving ocean-bearing worlds. When planets form, their water is contained in their rocks, but powerful volcanism causes this water to evaporate into the atmosphere. If conditions are right, the water vapor can condense and form a liquid ocean in which life might emerge, but the timing of this process remains uncertain. The Trappist-1 system is being studied to understand the effects of a water-rich atmosphere receiving only 10% more sunlight than Earth. This can lead to a vicious greenhouse effect due to certain gases, including water vapor. As water evaporates from the planet's rocks, water vapor in the atmosphere rises, ultimately causing the planet to become too hot and its crust and mantle to melt, creating an ocean of magma and releasing any remaining water trapped in the rock into the atmosphere. HD 219134b or HR 8832b. Planet HD 219134b is one of at least 5 exoplanets orbiting HD 219134, a main sequence star in the constellation of Cassiopeia. HD 219134b has a size of about 1.6 Earth radius and a density of 6.4 grams per cubic centimeter, and orbits at 21.25 light-years away. The exoplanet was initially detected by the instrument HARPS-N of the Italian Telescopio Nazionale Galileo via the radial velocity method. The Spitzer telescope subsequently observed it as transiting in front of its star. The exoplanet has a mass of about 4.5 times that of Earth and orbits its host star every 3 days. In 2017, it was found that the planet likely hosts an atmosphere. HD 219134b is a super-Earth with a radius and mass bigger than Earth but smaller than Neptune and Uranus. Its mass and radius have been accurately determined, allowing for accurate planet composition modeling. It has a rocky, Earth-like composition with a density of about 6.4 grams per cubic centimeter and 1.85 times the gravity of Earth. However, its equilibrium temperature is too hot for liquid water or life. Although it is difficult to determine whether exoplanet HD 219134b has traces of water, scientists have suggested that the planet's size and position within its star's habitable zone could make it a good candidate for water's existence in liquid form on its surface. Further observations and analysis will be necessary to confirm whether water is present on this exoplanet. GJ 1214b. Astronomers have been desperately trying to unravel the secrets of GJ 1214b, a planet 40 light-years away from Earth, for over a decade. They have been held back by a thick and impenetrable haze that has concealed the planet from their inquisitive gaze, frustrating their attempts to study its atmosphere. Enter NASA's stunning new James Webb Space Telescope, capable of seeing in the mid-infrared spectrum, piercing through the haze and revealing the previously hidden features of this enigmatic exoplanet. This cutting-edge technology enables astronomers to explore and discover new habitable planets and early galaxies, pushing the boundaries of space exploration to new heights. Scientists from the University of Maryland and the University of Chicago recently utilized the Webb telescope to study GJ 1214b's atmosphere. Their findings, published in Nature on May 10th, marked the first time astronomers have directly detected the light emitted by a sub-Neptune exoplanet. This type of planet appears to be the most common in the galaxy, but until now, it has never been studied in this way. Despite being too hot to support life, the team's research indicates that GJ 1214b's atmosphere likely contains water vapor and primarily comprises elements heavier than hydrogen. GJ 1214b was discovered in late 2009, but our understanding of it has been limited due to its cloudy atmosphere. This has made studying the planet challenging and frustrating, hindering our ability to observe anything beyond the clouds. The scientists concluded that GJ 1214b contains a significant number of elements slightly denser than hydrogen, which could be a combination of water, methane, or something in between. Additional research is necessary to identify the exact composition of the planet's atmosphere, but Kempton affirmed that the findings suggest that there might be abundant water present. Gliese 1214b. Did you know that Gliese 1214b is a mini Neptune? It's a smaller Neptune version with a rocky core surrounded by a thick gas blanket. This exoplanet is located in the constellation of Ophiuchus, approximately 52 light-years away. Gliese 1214b orbits a red dwarf star called Gliese 1214 every 38 hours at a distance of 1.3 million miles. It was discovered back in 2009 by the Me-Earth project. The planet is almost 7 times as heavy as Earth, and its diameter is about 2.7 times larger. Although Gliese 1214b is too hot to have liquid water oceans, it's still possible that water in vaporized form could be a significant part of its atmosphere. Crazy, right? In addition to observing Gliese 1214b, scientists used Webb's MIRI to create a heat map of the planet throughout its orbit around its parent star. The heat map of Gliese 1214b revealed details of its atmosphere's composition, indicating it is not mainly composed of lighter hydrogen molecules. This suggests a potentially critical clue to the planet's history and formation and could indicate a watery start. The discovery of exoplanets made entirely of water is an exciting development in astronomy. These 5 planets offer a glimpse into the vast and diverse universe beyond our solar system. While more research is needed to confirm their composition and characteristics, the possibility of finding alien life or habitable environments on these water worlds is intriguing. Such discoveries remind us of the wonders that await us in the universe. We hope you've enjoyed this video. Please be sure to share your thoughts down below, and as always, don't forget to subscribe to our channel for more thrilling space updates. See you next time.